All right, the last one we're going to look at is rational inequality. So once again, here are a couple examples of these. Very similar. We're just going to have to find some key points and then test within the intervals. So let me scroll down a little bit and we'll read these directions and look at this picture right here. So procedures here, basically you want to find the x-intercepts, or intercept, I should say. And the way you're going to do that is just set the numerator equal to 0 and solve. So just be careful because this point may or may not be part of the solution set. So for example, on this first one, it will not be part of the solution set because of the inequality symbol, because we want our solutions to all be less than 0. If it had the equals to part, then it would be part of the solution set. But since 0 cannot be part of the solution set, the x-intercept will not be included. Still need to find it though, because as you can tell looking at the graph, I'll scroll down a little bit further. As you look at the graph, obviously there's a sign change when you cross the x-axis, right? So that's a key point. So there's going to be two intervals, and one of those intervals will probably satisfy the inequality that we're dealing with. Okay, the second key point that you'll want to find is the vertical asymptote, okay? And so to do that, you set the denominator equal to 0. And so you solve that. Now that's definitely going to be off limits, okay? So it says note, it is excluded and can never be part of your solution set, okay? Because you can't divide by 0, so it's always the asymptote cannot be part of your solution set. But what you will notice is that at the asymptote, once again, there's a sign change as you cross this vertical asymptote. You can see that as I'm approaching it from the left, I'm getting all these positive results. But once I cross that vertical asymptote and we start looking down here, all my results are negative, right? So there's a sign change in your graph at the vertical asymptote. So just kind of like the other ones, what we'll do is plot those two values that we find from step 1 and 2, and then just test values within the sub-interval. And that's it. So here we go on this example. So if you want to find the x-intercept, you take the numerator, set that equal to 0, and solve. So here we'll divide by 3, divide by 3. So our x-intercept is going to be at 0. Now it will not be included, but we'll mark it on here in a second. Then my vertical asymptote, you take the denominator and set that equal to 0 and solve. So let's see. So the vertical asymptote is going to be at -6. So now we can go ahead and mark it. So we have one at -6, and we have another key point at 0. And you can tell by looking at the graph, if you go from left to right, you can see that when x is -6, there's a sign change in your y value in your results. Same thing at 0, you can see that the y value goes from being negative to being positive once you pass when x is 0. So to answer this, you could probably just do it visually, but you'll see moving forward, we won't have a graph for all the other ones that we do. So what we're going to do here is test some points. So we'll test, like, -7 would be a good one. You want to pick small numbers, keep your life easy. So let's see, we'll try -1 and +1 over there. Okay, so let's go ahead and plug it in and see what we get. So let's see, on this first one here, we're going to have 3 times -7 divided by -7 plus 6, and we want to know, is that less than 0? Okay, so 3 times -7 is -21, -7 plus 6 is -1, negative divided by negative is positive. 21 is not less than 0, so that's going to come back as false. So we don't want to shade, we do not want to shade that. We'll go ahead and cross through it. Oh yeah, by the way, both of these are off limits, so I should just go ahead and put open circles at them. Okay. All right, now we'll go ahead and test -1. Okay. So let's see, let's go ahead and plug in -1. So we're going to have 3 times -1 over -1 plus 6. We want to figure out, is that less than 0? Well, we end up with -3 over 5, -3/5. Yeah, negative numbers are less than 0. So this comes back as true. And so we'll go ahead and shade between. There we go. And just for good measure, we'll go ahead and check our last interval over here for 1. Okay, so we'll go ahead and let x equal 1. So let's see, 3 times 1 over 1 plus 6. Is that less than 0? We're going to end up getting 3 over 7, which is a positive number. Positive numbers aren't less than 0. So false. We don't want to shade right there. So the only interval that worked was that middle interval from -6 to 0. And there we are. That's my solution. All right, I think I got a couple more of these on our next slide, and that'll be it. Okay, so this time we don't have the picture to go with it, but it's the same basic deal. If you want to, if you want to figure out the x-intercept, you set the numerator equal to 0. So we'll take -x minus 3, set that equal to 0. I'm going to go ahead and add x to both sides, and that should finish the problem. -3 equals x. So there's my x-intercept. So if I plug that in, it causes it to equal 0, and the condition is that we're looking for values that are less than or equal to 0. So -3 will actually be part of my solution set. Okay, now for the vertical asymptote, we take the denominator and set that equal to 0. So we'll subtract 2 on both sides. So x equals -2. Now it's impossible for that to be part of my solution set. All right, so let's see, let's go ahead and mark this down. So let's see, we have -3 right here. We'll put -2 right there. So now it's time to test some points. So we can test like, -4. Now, unfortunately here, we're going to have to test like -2.5. It won't be that big of a deal. You'll see as we work through it, it's not that bad. And then over here, I'm going to test 0 just because 0 is easier than -1. 0 is pretty easy to plug in. All right. So let's go ahead with -4. We're going to test this. So let's see, we're going to have a -4 minus 3 over -4 plus 2. And we want to figure out, is that less than or equal to 0? So we just have to clean it up and decide figure out what we're dealing with. So the double negatives on top, they'll become +4 minus 3 over -2. And then 4 take away 3, it's going to be 1 over -2 is less than or equal to 0. That is true. Okay, because you got a -1/2 basically, and negative numbers are less than or equal to 0. Oh yeah, let's see. The -3 is actually included. So go ahead and close that in. The -2 is not, so I got to put an open circle there. So let me go ahead and shade, and we can talk about that again for a second. Okay, the reason -3 is included is that is the x-intercept, and so if you plug it in, it actually makes the expression on the left 0, and so you'd have a true statement: 0 is less than or equal to 0. If you plug in -2, you're actually going to get undefined on the expression on the left side. And so that is why it is not included. Okay. Now this next one, I know we have a decimal, but it's really not that bad. So let's see what we're dealing with here. So we have -2.5 minus 3 over -2.5 plus 2. And we want to figure out, is that expression going to be less than or equal to 0? Okay, so once again, you have those double negatives, so it becomes positive 2.5 minus 3 all over negative 2.5 plus 2. That becomes a negative 0.5. Okay. All right, and then when you simplify the top, you're going to get a negative 0.5 over negative 0.5 less than or equal to 0. Well, negative 0.5 divided by negative 0.5 actually turns to a positive 1 less than or equal to 0. That is false, okay? 1 is not less than or equal to 0, so we're not going to shade that area. Okay, our last interval over here, we're going to test out 0, and that should be pretty simple, plugging in 0. So let's see, you get negative 0 minus 3 over 0 plus 2. You want to know if that's less than or equal to 0. Well, negative 0 minus 3 is negative 3. 0 plus 2 is 2. So you end up with a negative number. Well, negative number is less than or equal to 0, so that's true. And so then we'll go ahead and shade here. Okay. And then the last thing we need to do is go ahead and write this in interval notation. So the first interval is going to be from negative infinity to negative 3, including it. Okay. Union. The other one's going to be from negative 2 to positive infinity. And there you go. Okay, let me see. Okay, I think I got. Okay, good. We only have one left. All right, here we go. The difference you'll notice on this one, there we go. The difference you'll notice is here it's actually set to greater than or equal to 3. And that makes this a pretty hard question, to be honest, in the form that it's in right now. We'll go ahead and make this a little bit more friendly to work with. Oh dear. Okay, so to make this more friendly, what we're going to do here is we're actually going to move this 3 over to the other side. And so in a moment, you're going to kind of have to remember some of our concepts for fraction, like adding and subtracting fractions. So in its current form, I can't really do much. I can't, subtract the 3 the way it is. But what I'm going to do is the LCD between these two fractions would be, x minus 2. So what I'm going to do here is I'm going to introduce an x minus 2 on top and bottom of this fraction right here with the 3 that I created. So the first one stays the same. I still have the x plus 1 over x minus 2. And then what I'm going to do is I'm going to put that 3. I'm going to introduce the x minus 2 here and on bottom. And so I didn't really change anything. I just manipulated it. I just introduced that x minus 2, x minus 2. If I were to cancel them out, I'd go right back to where I was. I mean, I don't want to do that, but just make that connection that these two things are the same right here. I just kind of introduced that LCD. So now that you have an LCD, you can bring this together as a single fraction. And so that's what we'll go ahead and do here. So I'm going to have the x plus 1 minus 3 times x minus 2 all over my common denominator. Okay, greater than or equal to 0. Okay. All right, so the next thing I'll want to do is kind of clean this up a little bit. So what I'm going to do is distribute that and combine some like terms. So let's see, I'm going to have my x plus 1 minus 3x plus 6 all over x minus 2. Okay. All right, so I'm going to just kind of keep scrolling down since I got more room down here. I'll scroll back up when I need to. So let's see. So I've got my x and I've got minus 3x. So that gives me negative 2x. And then 6 plus 1, that's going to give me 7. Then all over x minus 2, greater than or equal to 0. Okay, so feel like I should be done, but I just actually got started. So I had to put in a more friendly format to work with. So now I need to find my my x-intercept and my vertical asymptote. So if I'm going to find my x-intercept, I take the numerator and set it equal to 0 and solve. So subtract both sides by 7. Then divide both sides by -2. So I have double negatives, so it becomes positive 7/2 or 3.5. I like to keep it as a fraction. If you want to write it as 3.5, that's fine also. Okay. Then the vertical asymptote, you take the denominator and set that equal to 0 and solve, and that's not too bad. Go ahead and add 2. So x equals 2. Now the vertical asymptote definitely cannot be included. The x-intercept is up for debate. It depends on your inequality sign. Since your expression can equal 0, we want to know when it's greater than, but also equal to 0, and so that x-intercept makes it equal 0, so that's actually okay. So we'll go ahead and put these in numerical order. So we'll put the 2 first, and then we'll put the, actually let me move it a little bit further over. So I'm going to put the 2 here, and I'm going to put the 7 over 2 over here, which is like 3.5. Okay, 2 can definitely not be part of my solution set because it's the vertical asymptote. The x-intercept in this case can and is part of my solution set. So I'll go ahead and fill that in. Okay, so now it's time to test some points. Okay, so here, you know, 0 is always good to test, so we'll test a 0. Here, we know, oops, well, that's fine. Here we can go ahead, oops, actually, okay, then here we'll go ahead and test a 3, sounds fine, we can test 3. And then over here we could test 4, right? Because this is basically 3.5 down right here. So test something to the left, something to the right. Everything looks good. Okay, so you can plug this back into the original or the one that we kind of got going over here. I prefer to basically plug it into the one that we kind of put into a more user-friendly format. I think that would probably make life a little bit easier. So I'm going to be using this guy down here. Okay. So first we're going to plug in 0. Let's see, -2 times 0 plus 7 all over 0 minus 2. We want to know if that's greater than or equal to 0. So we're kind of asking ourselves a question right now. So -2, oops. -2 times 0, 0. 0 plus 7 is 7. 0 minus 2, so that's a -2. So we end up with 7 over -2, which is a negative number. So that means it's not greater than or equal to 0. So this first part is false. So this is not going to work. Okay, let's go ahead and try 3 now. So let's see, we're going to have -2 times 3 plus 7 all over 3 minus 2. We want to figure out if that's greater than or equal to 0. So let's see, -2 times 3 is -6 plus 7. 3 take away 2 is 1. Okay. -6 plus 7 is 1. 1 over 1 is greater than or equal to 0. That is true. So 3 works. So we can go ahead and shade that subinterval right there. There we go. Okay, last one we need to test is from 3.5 to infinity. So we're going to test the 4. So let's see, we got -2 times 4 plus 7 all over 4 minus 2. And we want to know if that's greater than or equal to 0. Okay, so -2 times 4 is -8 plus 7. 4 take away 2 is 2. -8 plus 7 is -1 over 2. Is that greater than or equal to 0? So that's our question. No, false, because we cannot have a negative is not going to be greater than or equal to 0, so that won't work. Okay, so we don't want to shade there. Let's cross it out so I didn't do anything by accident. Okay, so now what we want to do is convert that to interval notation. Okay, so that should be pretty simple. 2 is not included, and 7/2 is. So we'll bracket that in. There we go.